Hey everyone, this is Dr. Lamb, and this is the first in a series of mini lectures on modules 13 and 14, parameters and subprogram invocation for CS430, spring 2020. I will take all the videos and put them together into a playlist so that you can watch them one after the other or in whatever order you'd like. You can also rewatch things, you can pause, you can change the speed at which it goes, so make sure that you customize this to be best for you. Okay, so we're talking about subprograms and parameters for this module. Subprograms are really just the fundamental building blocks for programs. You've been using them ever since 149, and they're really best viewed as a form of process abstraction. You're taking sort of this solution to a particular small problem and you're packaging it up, and you're ignoring all the details about how it's implemented now when you call it from somewhere else. And so this facilitates modularity, which is this term that you learned about in 159 and code reuse. So generally, most subprograms in different programming languages have these characteristics. So they almost always have a single entry point. When you call a subprogram, the caller, the one making the call, is suspended while the subprogram is executing. And then after that caller after the subprogram finishes, control returns to the caller. Most subprograms, but not all of them, have names. Most of the ones you're familiar with have names, but a lot of languages have things called lambdas, which don't have names. We're going to make a little bit of a distinction between three different types of subprograms. So the general term is procedure. A function is a procedure that has a return value, and then a method is a procedure or function that is associated with a class or an object from an object-oriented language. There are a bunch of new terms here. I'm not really actually going to go through these in a lot of detail. All the definitions are in your textbook, so you can go and look at those. I want to go back to the difference between formal and actual parameters. So you learned about this hopefully in 149 or 159, but the formal parameter is the name of the parameter inside the subprogram definition. So whatever name it's given at the top of your function definition, that's sort of the formal parameter and the formal parameter name. The actual parameter is the parameter that is being passed in at the call site. And so there are three different semantic models for how parameters can work. There is the model where information flows into a procedure via a particular parameter. There's the model in which information flows out of the procedure via a parameter. And then there's a model where information flows both in and out of a procedure through a parameter. And notice this is in only, out only, and then in and out. And so those are the three main sort of semantic models. Now, we also talk about particular implementation models. So these are models that implement the various semantic models. And the differences here are what is copied and when is it copied. So pass by value is what you're familiar with from C. So it is an in parameter model. So when you call the subprogram, the value is copied from the actual parameter to the formal parameter, and then the subprogram executes. Pass by result, which is what you generally think of as being the return value of a function. This could be done explicitly using a named parameter. Not many languages do this, but that would be called pass by result. And in that case, information is only flowing out of the function, but it's still the value. There's also pass by copy or pass by value result, which is really just the combination of pass by value and pass by result, meaning that the actual parameter is copied to the formal parameter at the beginning of the function, and then the formal parameter is copied back to the actual parameter at the end of the subprogram. There's also pass by reference, which is also considered an in-out semantic model, but what's copied is not the actual value, it's a reference to that value. And so any changes that happen inside of the function happen to the thing that the reference refers to. This is what you're familiar with from Java, for instance. When you pass an object into a function, it's actually a reference. Pointers in C are also another example of this implementation model, where you pass a pointer by value, right? And then so if you make changes through the pointer, then it's sort of emulating a pass by reference sort of thing. There's also pass by name, which is not used terribly much, but this is an in-out model, and what's actually copied is the actual text of the program. Probably the pass by name that you're most familiar with is macros in C. So when you do a define and you define foo to be something, and then later on you use foo, then the text is actually being replaced by the preprocessor. And so that's an example of pass by name.